Hi guys, hi, how are y'all? Okay, so welcome. If you're watching this channel for the first time, my name is teacher Veronica, and um, I am just so happy that next week onwards that students can start going back to school, right? I'm sure most of you might be happy, some of you might not be, but despite everything, I'm grateful that you guys have been able to study from home. I'm also grateful that my YouTube channel has been helping a lot of you. You guys have like personally also messaged me, and if this is your first time watching, go and join our Telegram group. You can get a lot of help there if, let's say, you need help how to solve questions and all that kind sort of things. Okay, so let's get straight into today's topic. Today will be the almost last part of differentiation, which is rate of change. So you'll see how to apply the rate of change. Okay. Okay, what does rate of change here means, and what kind of questions usually can come out for rate of change? It's something that, like, for example, if you have a cube or a cuboid, and then the water, level increases inside a cuboid, or the water level decreases inside a cube. So all these changes are happening, right? So that's why you need to learn how to apply the gradient, the dy dx that you find into these changes that's happening. So usually, if let's say your changes, the value you get positive, that means the changes is the quantity is increasing. If let's say you get the value of dy, the rate negative, that means it's decreasing, the quantity is decreasing. So let me actually show you with example, then you will really understand how this thing works. So application, this is already the application part of the rate of change. Okay, so rate of change, actually usually we will use dy dt. Okay, dy dt, because change is happening with respect to time. Okay, with respect to time. So usually the with respect, I will just write wrt. Yeah, so make sure you know that wrt means with respect to. Okay, so when something is changing, it changing because of according to the time. So as time is going, the changes is also happening. Okay, so in this case, the dy dt here will be equal to, okay, equal to dy. Okay, write the dy on top. Okay, then over something times with, okay, dt will be over here. Okay, because since we want the dy dt, that means this part here, okay, and this part here, the differentiation will be the same. So what usually it will be dx, okay, dx. So dy dx times dx dt, because the dx, when you cancel off, okay, you do get back the dy dt. Okay, so now let's look at example. Okay, teacher is going to show you guys example so that you can clearly see how this formula works. Okay, now let's look carefully at this example. So given that y, okay, the function, the equation y is given, x squared plus 4x plus 3, and the rate of change of x is 0.5 unit per second. So unit per second means the changes is happening every second, so 0.5 per second. When x is 2, find the rate of change of y. So when they ask you to find the rate of change of y, that means they want dy dt. Okay, that means they want this dy dt. Okay, so since now that we know that the formula is you need to have dy dx, and then you need to also find dx dt. Okay, so now, okay, look carefully. Rate of change of x. Okay, whenever you see the word rate of change, okay, remember it's always with respect to time. So this one, rate of change of x, is actually dx dt. Okay, that means the dx dt already got ready, which is 0.5 unit per second. Okay, that means dx dt got already, yeah? Okay, so the change is happening when the x is equal to 2. All right, now we need to find, okay, so that means here, okay, if you can see this closely, here the green color one got, we can substitute. So all we need to find is this one, dy dx. Okay, we just need to find dy dx. Okay, how to find dy dx? Very simple. Go back to the equation there. Okay, the y is x squared plus 4x plus 3. So when you want to find dy dx, you differentiate. So we will get here 2x plus 4. Okay, done. But you cannot substitute 2x plus 4 inside the formula, because whenever you have rate must always have numbers, values, integers. Like for example, this one is 0.5. So the dy dx will be what? Okay, since they say that this change is happening when the x value is 2, so you are going to substitute the 2 inside here. Okay, so I'm going to substitute x equals to 2 into my dy dx. Okay, so when you substitute, you will get 2 times 2 plus 4, which is 8. So that means the rate of change here for the dy dx, right? The y, here we get 8. Okay, so now you can substitute all these values inside, right? So we can substitute all the values inside to find the dy dt. Okay, so now I can do dy dt is dy dx, okay, which is 8 multiply with 0.5. Okay, so 8 times 0.5, we get 4. Okay, that's all. So this is our rate of change of y. So usually the units you don't write down, but if let's say you also still don't write down, you can write unit per second, because over here there's no unit for the dy dx, so you can just write unit per second. Okay, so teacher hope you understand this, because this one is like the simple rate of change question. Okay, now let's go to maybe a little bit more like challenging type. Okay, now let's look at an example that most of the time you need to know the formula of volume or area of all the cube, cuboid, baby pyramid, you know, all these things that you learned last time when you were in form 1 to form 3 cylinder. So if you are doing your own notes, it would be good that you do a side note for volume, area, and all these things. Okay, okay, so teacher is going to continue with this question. So do pay attention, because you just need to know a certain trick how exactly to solve this, and then you will be able to solve most of the times. Okay, okay, the side of a cube increases at the rate of 1.4 centimeter per second. So the side is increasing, meaning that let's say a normal cube, okay, it's from a normal cube like this. Now the side, right, this, let's say this part is the side. Okay, the side is increasing, that means it's becoming bigger. Can you see? So that's why this is called changes. Okay, the changes that's happening here is it's becoming bigger, the sides is becoming bigger. Okay, now, so the rate of change, okay, find the rate of change of the volume when the sides measure 5 centimeter. Find the rate of change of volume when the sides measure 5 centimeters. Haven't 5 yet, okay. So the beginning, this is, let's say this is the beginning. Okay, this is the end part, like already after increase. Okay, now during the beginning, do we know how much is the side measurement? No, so we just write S first. The end one, do we know? Yes. What do we know for the end part? We know that it's 5. Okay, hold on, let me erase this. Okay, this is 5. Okay, wait a minute. Let me just erase properly. Okay, done. Okay, so this is 5. I want this color. Okay, 5 centimeter when the sides already increase. Okay, let's look carefully here because sometimes you don't have to use dy dt. Sometimes you have to use other letters. Okay, so what letter are we going to use here? Let's check. They ask us to find the rate of change of volume. So when they say volume, that means is dv dt. Remember, whenever the word rate of change comes, down must have the dt. Okay, up will depends on the second uh, whatever they are saying on the second part, which is volume, or find the rate of change of area. If they say find the rate of change of area, so it's dA dt. A for area, dt is for the rate of change. Okay, okay. So since we want to find the rate of change of volume, okay, so you can compose the formula here. Okay, write the dv up. Okay, write the dt down. Okay, now can I write down here dx and up here dx? Do you think it's going to be a yes or no? Okay, uh, I don't know what exactly you think, okay, but it's a no because, okay, listen carefully, because this volume is changing because of the sides, isn't it? Because the side is increasing. Okay, since because the side is increasing, so changes is happening because of side. So this is going to be ds. So if you realize here, there's only two things here. One, the V, the volume, which they asked you to find. And then they said the S is the sides. There's no other information here given. So that means we just need to focus on this. Okay, Ken? So far? Okay, I hope you are following because these questions are very important. In exam, this is like popular. Okay. So, okay, let's check what we already have for the formula because we're supposed to find this, okay? This one need to find. So, let's see what is given. So, the side increases at the rate of 1.4. So, side is given. That means ds dt, okay? ds dt is given, which is 1.4 centimeter per second. Okay, done. So dv ds only don't have. All right, so now how to find dv ds? Okay, let's see. If I want to find dv ds, that means I have to differentiate the v, right? Okay, you have to differentiate the v, which means the volume. So volume of cube is usually what? I think all of you should know volume of cube is usually quite simple. You just need to take the length times base times width, right? Okay, so the length times base, okay, times the width. Okay, so in this case, usually for cube, all the side measure the same. So here, we take the beginning one, which is s times s times s. So that means this is s cube. This is the volume, V. Okay, don't put the 5, the 5 not yet, because if you go and put the 5, okay, the volume, let's say 5 times 5 times 5, so you'll get 125, correct? But then how are you going to differentiate this? Cannot differentiate, right? Okay, so don't do this mistake. Okay, do not do this mistake. You just have to check which one you're going to differentiate. Okay, so if you see here got V, here got on the right hand side got s. Okay, so correct already, yeah? So now we can differentiate. So let's find dv, differentiate v with respect to s. So here 3s squared. Okay, done, that's all. Okay, now dv ds got ready, but you need to get it in value. You cannot substitute with letter. Okay, now is the part where you substitute the side. Substitute S equals to 5 cm because they want when the measurement already increase. Okay, 5, 5, 5. So that means dv ds will become 3 times 5 square. So 3 times 25 will be 75. Okay. So this is our dv/ds. So dv/ds got, ds/dt also got. So now can we find our dv/dt? We can apply everything right into the formula. Okay. So let's do that. So dv/dt equals to 75 times 1.4. So let's check. 75 times 1.4 is 105. So I can write centimeter per second. Okay. I really hope that I explained this clearly to you guys because this is very important. Okay, so teacher hope you guys try. Okay, try like this question. So make sure you know what is changing, what is the rate of change, because not always is dy dt. Yeah, sometimes you see can be dv dt, sometimes can be dA because area. Okay, so just have to, usually it's area, volume, this only. Okay, so just have to play with that. Do a lot of practices on this. Okay, so I'll see you for the last part, which is the small approximation changes. Okay, I'll see you for the last part. Okay guys, thank you so much for watching until the end. I'll see you in my next video. Don't forget to subscribe. Okay, bye.